Okay, so in this video we will talk about how to do some programming with the command line interface. That is how to do scripting. So we'll start by refreshing programming by command line interface, what we've seen before. And then we'll go into more complex examples, so more scripting-like examples. So this is what we've seen before. So we talked about that the graphical user interface is a purely user interface. The API is an interface for programs, so it's used to write programs. The command line interface, on the other hand, is a hybrid. It's a user interface, but it can easily be used to write programs. So for instance, it's this example we have. It's easy to combine two commands. So for instance, ls here, and the output of ls, and use the word count program on this one to actually just count the number of lines in a file, the number of lines in the output to get the number of files in this directory. We also had this exercise where we had the file explorer showing many dated report files, and then we had an exercise that we were supposed to print the contents of specific files, and in this case we were supposed to take the contents of all reports from the summers of 2005 to 2008 and put these into one file. And we also concluded that this could be done with one line on the command line. So this line. We also noted that if all files are in the same directory, we can replace this part with ls only. But this one allows us to do this across directories as well. So the first part simply lists the number of all the files that are available. The grep utility filters them based on the years 2005, 6, 7, 8 and the months 6, 7, 8. And then the final one simply prints the contents of these files. Now, let's continue with scripting. Okay, so scripting. Let's make our exercise a bit more challenging. So we have all these reports, same as before. So lots of files named by date. Now, what we want to do is first sort the reports into subdirectories, one directory per year. So we don't want to have all these reports just lying in the top level directory. We want to have a number of directories, so 2001, 2002, and so on. And then all the reports for 2001 should be in the 2001 directory, and so on. Second, for each year, we want to sort these reports into subdirectories: summer, autumn, winter, and spring. So all the reports for 2001 and the months June, July, August, they should go into the summer directory. And then the same thing for the autumn, winter, and spring months. So that's what we want to achieve. So let's switch to the virtual machine and have a look at what we want to do. So we have the terminal, and we see that it's the same files in the terminal. I run ls here, so it's the same files as in the graphical user interface. And what we want to achieve is when we go into the directory, we have the years. If we go into 2001 and we go into autumn, we find all the reports here. Now, and this is what we have to work with. So let's go and fix these reports. So the first thing we want to do is to create a 2001 directory. There we see we have it. Now we want to move all the 2001 reports. So we use this asterisk as a pattern matching. So this is a glob pattern. So not the same type of patterns that are used for grep, for instance. So this is used in the terminal for files. So all the files starting with 2001 and a dash, they should be moved into the 2001 directory. And when I press enter now, we see that all the 2001 files disappeared in the graphical user interface, and they should have gone into the 2001 directory. So let's go in there and have a look. So if I look there, we see that I have all the files in there. So let's do the same in the graphical user interface. Now, what we want to do here is the second part of the exercise, to sort the directories, sort the files into the directories autumn, winter, spring, and summer. So let's start with the winter directory, and there we see it appears. So winter, if we that starts with December, and then it includes January and February. So we want to move all those into the winter directory. So now we saw that all those January files disappeared up in the graphical user interface. And next is spring. So create the spring directory. And then we move all the spring months, so starting with March, followed by April, and finally we have May. These go into the spring directory. And then we see that that happens. So then we take summer, we create the summer directory, and then we move the summer months, so June, July, and August into the summer directory. So we see that if I just write a few characters and then I hit the tab key on the keyboard, then the terminal will automatically complete the remaining parts of the file. So if I write SU and then I hit tab, it completes the summer. So that was summer. Left is autumn. And then we move the 2001, and let's see, what are the autumn months? It starts with September, and then October, and then November, and they should move into autumn. So AU, and then I hit tab, and the terminal will fix the rest. And that was all the reports, and now they are all sorted into the correct directories. Now, what? Now we have all the remaining files in here. So we have sorted the 2001 directory. Now we don't want to repeat this, neither in the terminal nor by hand in the graphical user interface. So what we want to do is to create a script that does this for us. And we can say that, well, what we have done is exactly the same, and it will be exactly the same for all the other years. The only difference that we will have is the year. The year is the only thing that will vary in this case. So for this, we can actually start by using the history command to see our command line history. And yeah, we have done some things. So what we want to do is to take the 20 last commands and put them into a file. So if we type history 20, it just prints the last 20 commands. So we can do history 20 and store that in a file. So we can call that one sort.sh. And now, what do we want to do here? We can open the sort.sh and see that, okay, it has all the commands that we had. So let's remove these numbers because those aren't interesting. And then let's see, it started here. So this was what we did, and then we can remove the last few lines. So these were the lines that actually did this for us. Okay, so we can save these, and we will need some tool for this, so we can have a look at variables that are really useful. So the first thing that we will have a look at is arguments. So arguments for positional arguments are special variables that one can use to take arguments to a command. So we will do a short script to demonstrate this. So we see in the slides that we have args.sh, and it contains the lines echo fixed, and then 1, 2, 3, and then we have order $1, $2, $3, and then we have on order, which is $3, so it's in reverse order essentially, and $1. So that's exactly what it says on the slides there. Now we can run this one using bash, because that's what the interpreter that we have, the shell interpreter. So that's what's running in the terminal window here. It's bash that's processing our commands that we are typing in. And we can type bash args.sh because that's the file we want it to run as if we are writing them. And then we see we got some errors. So first it writes fixed 1, 2, 3, but as we can see in the slides, I did forget to type echo. So it simply says line 2 order command not found, and then line 3 unorder command not found. So if we look here, yeah, indeed, we forgot to type echo on these lines. So let's fix the problem and let's run it again. Now we see that it doesn't complain, but it types fixed 1, 2, 3, and then it types order, and then it types unorder. And the reason is that we did not provide any positional arguments. So if we do as it says in the slides, we add 1, 2, and 3 here, we see that the result is that order is 1, 2, 3, unorder is 3, 2, 1. And if we go back to the script, we see that, of course, the first thing that comes is on the line is number 1, and then the second is number 2, and then number 3, and so on. And here we put 3, 2, 1, so then they are in reverse order. But it doesn't have to be 1, 2, 3. We can type something else like hey po day, and then run it, and it comes in reverse order. So if we type just 2 things, we see that the third one will be nothing. So it essentially reverses the order anyway. If we type 4 things, we see that the fourth thing, med, is ignored because we didn't use $4 in the script. Now, so this is particularly useful to pass data into a script. And we have another aspect of variables. So these positional arguments, they are variables. So 1, 2, and 3, they're $1, 2, and $2 and $3, they are variables. But one can have other variables too, which are named in more understanding way. So we can try this. We can try this vars script and type it echo hello world exclamation mark, and then we can have a variable named who, and then we type world with a capital W, and then we do echo hello and then $who and exclamation mark. Okay, so then let's try to run this one. So then we see we got hello world and hello world. So one with uppercase and one with lowercase world. And then let's say we can change the world into Daniel and save, and then we run it. So then we see that it writes Daniel instead of world. So just changing the who variable. So essentially one can think of these variables as something it's substituted for the value it contains when this script is run. Now, how can this be useful for us in our case? Well, if we edit our sort script, so we have done something here, and we said that the only difference for doing this again for the other years is the year, because the year will be different. So we create a different directory. We will move the different reports starting with 2002 instead of 2001, for instance. And then we will go into that directory. And then we will create the winter, spring, summer, and autumn directories and move the reports, the corresponding reports in there. And the only difference will be this year. So it would be nice if we had some way of varying the year, and what will be better than a variable. So we can create a variable called year, and we actually want to have the first positional argument when we run this script to be the year. Now, this means that we simply store one variable value into another one, and we do that to make this more readable, because it's more readable to have the code here say year instead of having it say $1. So we prefer to have $year. So that's why we simply take this value of $1 and put it in $year instead. Now, so all we need to do here is to change the 2001 into $year. So I just did a search and replace for all of these. So now we see that it's the year instead of 2001. Let's save and exit to see what we do. We can remove this ls command because that's not necessary for our script. We don't need to look into the directory as we did when we were doing this by hand. So this is the part where we create a year and we move the reports into the year, and then we go into the year directory, and in here we create the winter, spring, summer, and autumn directories and move the corresponding reports in there. So let's see if this works. So we have all these, and we had created this script called sort. So bash sort, and then we needed the year. So let's do 2002 then, because those are the next in line up there in the graphical user interface. So let's see what happens. We see that up here, we got the 2002 directory and all the 2002 reports disappeared. If we go into it, we see we have autumn, spring. So let's look into autumn, and we see that it's September starting. and it ends with November. So this actually solved our problem. So then we can simply do 2003 and same thing happens. So this actually solved our problem, and now we just have to do this for each year like this, which is much easier. However, one could script this further, so we don't have to type the years by hand. We know we had until 2009, so one can use the sec command, for instance. So next one is 2004, and the last one is 2009. So what this command does is simply to generate all the numbers in between. So something, anything from 2004 to 2009. So we see that it creates all these numbers, outputs them. We can pipe these to the xargs command, and then we have we use echo to see what it actually prints. So we see what passes there, and then we see that it passes it like this, and that's because xargs by default takes everything, all those lines, and add them as argument to echo. So, and that means echo will print it on one line. However, if we pass the argument n1 to xargs, it will simply take one at a time and pass it to echo, which means it will look something like this. This means that we can do something like this. So we had our script that was sort+.sh, and if we run it like this, so we see then what happens is that we get bash sort and then 2004, 2005, 2006, which is exactly what we would do if we would run it. So what we do now is to simply remove this echo, and instead xargs will execute bash sort and then the year. So if we run this, then it should sort our entire directory, and it does. So we have no reports left. They are all sorted into the directories. Now, what was the interesting part here, the crucial part of the script, was the variable, so that we could actually use to vary the year for all these commands that we did. So it's a very useful thing to have variables, to let them vary when all the actions will remain the same. And it's very useful to be able to write these scripts. So for instance, the grading scripts that are used in this course, they are actually written exactly like this. So they are a bit more complex, of course, but they are written like this. So for instance, this one goes through all the students' home directories and separates the student and the home directory, and then the history file, that is what you have to produce in the assignment, those are graded, and if it's a pass, then the grade is reported to the Canvas LMS system, so the learning management system. So with a P, so a pass. And otherwise, it's graded with an F, and feedback is inserted into Canvas, so you can actually see why you didn't get a grade on that assignment. So you can do quite a lot with shell scripting, as this is called. That was all I wanted to say about this.